As the outbreak of COVID-19 has escalated to pandemic proportions, most municipalities are operating under a state of emergency, and critical patient care depends on the ability of healthcare providers to make important decisions quickly and without error. A high-performance physical infrastructure can help you feel confident that the technology you are using is reliable and available when needed. I'm Ed Murray, Content Director with IDG, and today we will learn more about how connected buildings help support the convergence of healthcare facilities and campuses. Let's meet our speaker. I'm joined today by Jill Shea, Director of Business Development at Panduit. Welcome to the webcast, Jill.
Hi, Ed. Thanks for the introduction. I have responsibility for our global enterprise business development team here at Panduit. And our team works a lot with our sales as well as our product teams to break into new markets and to continue to research existing markets, along with, kind of just increasing our overall intelligence in the overall business community. One of those important markets for Panduit is healthcare, where downtime cannot be handled. I look forward to our conversation around this topic today.
Thanks for being here, Jill. Well, we've got a lot of great material to cover today, so I'm going to hand it over to Jill to take us through our agenda and get started. Jill.
Thanks, Ed. There's a lot going on in healthcare today, and Ed opened it up a little bit, certainly with what's on top of mind for all of us today around COVID. But there's also everything on a normal day in the healthcare industry. There's a lot going on. So today we want to take a look at some of those trends that are going on globally, as well as how this relates to the industry's digital building trends and the technologies that are involved. This all relates to the strength of the infrastructure today and the plans for it in the future. So we'll walk through these topics as we move on with our conversation.
What are some of the top challenges for healthcare operations management today?
I think one of the major changes or challenges has to be that healthcare has tons of data that they now have access to. And this enables, them as well as us being the consumers. I mean, it's not like in the past where you just went down the street and you went to your local hospital and you really didn't look as a consumer as to what your choices were. Now with that amount of data as well, as far as what their scores are, what the experience is, and all of that all plays into the experience that the consumer is expecting in the healthcare industry. And it's actually changed the way that healthcare industry has to almost recruit people to come into their facilities now. And so that is certainly a different challenge for the healthcare space that enables them to have to think differently and almost, I don't want to say be a hospitality type of an environment, but it kind of challenges them to think a little bit in that way. As well as there's a lot going on from procedures being done more like in storefront locations. So healthcare has changed. So we used to just go to a hospital, and that's where you had both your day surgeries, your in and out surgeries, or your stay overnight. Now you might find a lot of these facilities located almost like in a storefront, making it more convenient for you or I to be able to go have some basic procedures done without having to travel a larger distance to a hospital itself. So there's changes in both the way that the consumer is working as well as the healthcare facilities are providing those types of services. And with this more mobile, connected society, healthcare workers are also bringing devices to work. They kind of have that BYOD that you hear a lot in other industries, and that's bring your own device, which enables them to access information more freely, but it certainly creates quite a few challenges for the facilities themselves. And these devices are connected through various different ways inside of buildings, with Wi-Fi to increase the mobility. Understanding what this means to the network and staying up on standards in a rapidly changing wireless world can certainly be a challenge. So let's talk about some of those standards. Certainly, healthcare has many of those that the industry needs to understand as it relates to new technology. Even though it may appear that enabling these may cost a lot of money, maintaining older infrastructure can also be extremely costly. So not only can a robust, up-to-date infrastructure help in increasing a facility's efficiencies, it can also reduce their maintenance costs, which both of these can help to increase the facility's efficiency.
That's a lot of challenges, Jill. Much like many of the other industries that we see, going through all these technological upheavals and transformation, yet with the added challenge of being a healthcare operation itself. One of the things we hear a lot about is the Internet of Things. And the Internet of Things is an important trend that has implications for the health industry. So I'll look at the top of the slide here. Why does healthcare need IoT?
So in our previous conversation, we touched a little bit on how healthcare has had to adapt to the patients as a consumer. And that's around data, how it's used and derived, and how it can drive a lot of differentiation. With data, there's certainly security concerns around this, both physical and cyber, that will have to be taken in consideration. But let's dig into the data a little bit. As we enter into the world of AI and enabling the data that's being collected on a patient or inside a facility or a clinic or even at home, this data can enable a healthcare provider warnings before something happens, or data that as it is happening and an event is being recorded or occurring, they have that data as soon as they walk in to know what happened right before or during an event to help them make those decisions faster. And even telehealth, I can't remember in the past, if you needed to go see a doctor, you had to go find a doctor to go into their physical facility. Well, now telehealth, we have that capability to dial in and talk to a nurse or a doctor. There's certainly that need of having that increased data and that data at your fingertips. And not only is this data about the actual patient, but it's also about the equipment and how and where it is being used to determine the increased efficiencies of those pieces of equipment and to determine if I need more of them or less of them, which of course can overall reduce the cost of equipment. Because in the past, you didn't really know how often a piece of equipment was being used. And now with the acquisition of data, it can help you validate whether you are using it at its 90% capability or whether you're only using it 20% of the time. All of the above is IoT and the enablement of that data that we can obtain to help us to make better decisions quicker, thus increasing the safety and the health of the patient and increasing the efficiencies of the provider.
Like almost all other industries, healthcare is undergoing a digital transformation revolution of its own. Can you give us a snapshot of where healthcare is today in terms of digital technology?
Well, yeah, I think if we just take a look at the list that's here on this page, it helps us to understand, what the world is today and what's going on. We have robots that use data and other doctors to perform more precise surgeries. So you have multiple things that happen just in an operating room. That robot is able to do more precise surgeries. You can have another doctor sitting in and observing a surgery to help the physician that's there on site perform it in a different type of a way or with different types of procedures. Not only is this happening in operating rooms, but it's happening all over a hospital. Just think about a patient room and the number of normal devices that require connectivity. Hospital beds are automated now. All of the devices that sit inside of their room, plus we're not even talking about the consumer's BYOD device that they're going to want to be able to be connected with when they're inside of the patient room. The wireless networks require them to be extremely reliable, as well as the wire to achieve the results from these types of devices. And even the overall connection to all of the healthcare wireless equipment and the experiences that need to be happening. All of this requires the best network availability and the lowest latency for the healthcare staff as well as the patient.
Jill, I'm going to let the title of this slide ask the obvious question. What is smart healthcare?
I think the most important thing here that we have not already discussed is just how rapidly the market is changing and what the future holds. This allows us to understand the importance of this, especially in the healthcare space, as well as we understand some of the other challenges the industry has and will continue to face. Let's just look at some of the data here and some of the market insights that we see here on the screen. 1.3 trillion in IoT spend in 2019, a 690% growth in IoT-enabled devices, 2.8 billion connected things. These are all really large numbers and large growth for an industry that for anybody would be a challenge. And especially inside of the healthcare industry that has a little bit more stringency around standards as well as patient security and safety. That's what makes it even more critical.
Again, this slide asks its own question. What is a digital building anyway?
A digital building is the convergence of things from IoT, analytics, power over Ethernet, and the network itself, and everything that brings it together. It includes building automation systems, which we might call BMS or BASs. It includes things like PoE lighting, physical security devices, audio visual, and all kinds of other sensors, software, and analytics that pull all of that information together. All of these aspects can be supported on an all IP network. Power, management, and control all on the same infrastructure. From the image that you can see here, a digital building has many parts, and they are all tied together with common infrastructure. Let's walk through maybe a little bit of an example, maybe even in a healthcare facility. Let's say that you've entered a facility and you're there for a procedure. You check in at the front desk. The lights in the building help you to direct you to where you should be going. They kind of know when you get there. It enables you to then check in at that location. Someone comes to visit you while you're inside of the facility. They're automatically able to know where you are. And again, those lights can automate them to where you are. Inside the building, let's talk about lighting. Lighting can automatically know based on sunlight outside is the type of light that they need to have inside the building. The window coverings and HVAC systems can be automatically adjusted at night. When you know a healthcare provider still have to be able to see what's going on with you and anybody else inside the facility, but you don't want to have a bright light on, things automatically turn into an amber light so that that can still happen, but you're still able to sleep. Imagine a camera with facial recognition allowing you to enter certain rooms or maybe even an ID bracelet. Digital buildings have so much that they can offer, including when we talk about even natural disasters or a fire. Those buildings can automatically respond. So in the case of a fire, lights can all come on in a building. They can direct you to the closest exit, and they can turn off the HVAC system, which is one of the most important things when we talk about those types of instances. This shows how disparate systems today could communicate in the future. And these types of scenarios using both wired and wireless devices and require all of these unlike systems to communicate. We're not there yet. There are certainly technologies and standards that are helping us to increase that adoption.
So how does all that uniquely translate to a healthcare environment?
So we've been discussing a little bit around the patient as a consumer and inside of a digital facility that can certainly help to increase the patient's experience, to as simple as it being remembering bed positioning, TV stations, lighting, as well as simplifying check-ins or maybe even a telehealth video conference. The digital facility is not all about the patient, but also about the workforce itself. From secure messaging to 24/7 access to records to data real time, which we spoke about a little bit earlier before, on the equipment, leading the provider to be able to make a faster and more educated initial response. What if a patient who is being monitored has an event and that happens and they require immediate response? Typically, when a provider would walk into that room, they would see what is going on now. What if the system could automatically create a report with everything that was being monitored right before and during the event to enable that quicker response? That's kind of all around where this digital hospital could lead us, from an overall data as well as AI, or even where a piece of equipment is located inside of a facility to help you find it quicker. Of course, a digital healthcare facility can also help you to save on energy, such as lighting and HVAC, by knowing which areas are in use and which areas are not.
So let's dig into some of the details. Most people know about three common utilities: water, gas, and electric. But a building's network infrastructure and architecture is becoming just as important as those other basic services, right?
Yeah, it really is. And it is that data/information highway. Now we can start to talk about that as kind of the foundation of the digital building. The building's network architecture should be the first phase in deploying a successful digital building strategy. And that's what we're starting to call it as the fourth utility, is the network itself. This exponential increase in connected devices in a facility is creating that trend towards network convergence. The unprecedented volume and diversity and speed of the data being generated, the common building platform emerges as a cost-effective alternative that will support future applications moving through the digital building's journey. And when we think about what a utility is things that provide essential services that people have to come to depend on. And that's certainly from a network perspective, whether it's inside of a healthcare facility, inside of our office, or even inside of our home. I would have to say that we've probably become pretty dependent upon that IP network as pretty much a very core piece of what our requirements are.
I couldn't agree more, especially these days. When we talk about network convergence, bringing multiple communication modes, such as telephone, video, and data, together on a single network offers a flexibility that's just not possible with separate infrastructures. What other benefits are possible with network convergence?
Well, there are certainly things from a maintenance aspect when we think about similarity in management, increased flexibility, and the ability to share anything with anything. The one thing that we have not discussed is the capability of power. Everything needs power, whether wired or battery. And now with Ethernet, and the increase of power through PoE, these same copper communication lines that you're using today to now connect your IP system with can also power those edge devices, reducing the cost of having to run a separate piece of copper. All in all, by integrating control, data, and devices, we can optimize building management, improving employee productivity, and providing new business opportunities that are not possible with separate network infrastructures.
And maybe we just get a little bit closer to that world without wires that we all dream a little bit about. So what steps can hospitals and providers take to ensure that they're creating a healthcare ecosystem that's ready not just for today's technology, but for advancements we might not even know about yet, but that we know are coming?
Yeah, as we talked on the previous slide, convergence, as I put it in my air quotes here, it brings with it many benefits, but also many challenges. One of the biggest ones is to make sure that the entire team is sitting around that table, from IT, maintenance, facilities, etc. Today, all of these teams or individuals have responsibility for various pieces of the building. And if they're not sitting around the table and having a conversation and talking about what is required for the network, you could have various different specifications inside of one building. You could have various different types of suppliers or manufacturers doing the same type of capability inside of the building and similar contractors doing the same work, which certainly provides a very different challenge in the fact that you're probably paying more and you don't have commonality. So one of the biggest challenges that you can think of from a healthcare facility or any facility that is in this convergence is to make sure that all teams are around the table and talking about what convergence looks like and how it's going to be managed. And the important thing is that as we continue to install these types of networks in the future, is to make sure that we're enabling them to be future ready. Whether it's how we're laying in our backbone or how we're zoning or laying out the facility for future installations without having to run connections all the way back to our TR. We want to make sure that we're working with certified installers and partners that can help us to understand what the future of our infrastructure should be looking like, as well as remembering that infrastructure itself is typically pennies on the dollar when you look at active devices. So a few more pennies to create a more robust future-ready network is probably worth it. The other thing to keep in mind is that facilities, especially inside of healthcare, going into the ceiling is not a place that we want to be accessing on a regular basis. So making sure that we have easy access points to be able to add those additional devices in the future. Enabling people to focus on what they're there to do and creating an overall competitive advantage enables healthcare to kind of differentiate itself here.
Okay, Jill, TIA 1179. What is it and why does it matter?
So TIA 1179 was ratified quite a few years ago specifically for healthcare facilities. And I think one of the major reasons that was put in place was because we all talk about space inside of a building or really any place, right? We want to optimize the amount of usable space. Even inside of our own homes, we want to optimize the amount of space that I get to use. So from a healthcare facility perspective, if I'm working with an architect and an IT person says, hey, I need X amount of space to be able to put all my equipment, well, that's not usable space for them to be able to earn money with, right? It's actually kind of dead space from that perspective. And so that kept getting squeezed and squeezed. And so it was very, very difficult for IT to find spots to put things. And so I think what ended up happening from an 1179 perspective, it enabled that discussion to have to happen at the forefront so the amount of space was set aside. It's important to have that space for future upgrades as more and more devices are coming onto the network, and the standard lays out situations that may impact the telecommunications room in healthcare that everybody should be aware of. For example, you need to make sure that you have additional TR rooms if the floor is being serviced with over more than 1,000 square feet. Category 6A cabling is the recommended minimum. OM4 fiber is the recommended minimum for multimode optical fiber. A minimum of 2 fibers are now required for an optical fiber backbone. Some of the other requirements that are pointed out in this documentation as well is around what telecommunication pathways and spaces are, the type of bonding and grounding that needs to happen, as well as cabling to wireless access points and distributed antenna systems. All of this helps us to plan a better system and things that we were discussing on previous slides to make sure that the facility is ready for today and into the future.
It's really about planning things out from the beginning, not necessarily after the fact. So can you take us through how hospitals evolve from separate building systems to a converged building?
Yeah, there are 3 main elements that go into a converged building: security, building automation systems, which is kind of the environment, and communication, which is data and voice. In the past, all of these have been separate. Today, these separate systems are converging onto one system. Now, don't get me wrong, we're not there yet. It's not like every system has everything IP enabled. There's still a lot of work to be done, but there are pieces of it that are starting to come onto the network where the rest of it may still be some ancillary or hardwired or whatever types of communication. But that larger amount of data is enabled to be shared at this point in time. And there are a lot of things that are happening now that will help that convergence in the future. All of these systems create data, and analyzing that data gives you more information about the building that can lead you to a better working environment. The data is stored in the data center or a cloud. Enterprise and data center systems work together to form the company's data center or even a third-party data center, on-prem or off-site. Information has to be collected somewhere. And so now this is enabling it all to go into one common spot. And this slide here kind of walks us through what's changed. With separate networks and systems, you had all different types of connectors and sockets. And all of this now combines into a single type of cabling with a single type of connector on the end of it, which allows us to make that overall more interconnection in the overall space as we move forward.
This includes everything from lighting to HVAC to security as well?
Yeah, it does. A drive for network convergence onto an all-IP network with power over an Ethernet applies to everything. Security cameras and sensors are connecting with building automation systems. Buildings are becoming smarter by being able to know when people are there and when they're not there, can manage temperature and lighting to save energy. Employees' identification badges can let the building know that they are there and set their preferences inside the building or at their desk or their workstations. Audio video can be used to control building management systems and setting preferences. We are seeing all of these devices talking with all the connections. This is the world of the Internet of Things that is driving business. A converged building provides new opportunities for connections and central monitoring and management, making a more productive workplace.
So does that mean Wi-Fi and distributed antenna systems can work together, can actually complement each other?
Yeah, it's a pretty hot topic today. And each one of these systems certainly has its strengths, and they certainly have a commonality. So let's kind of walk through which each one of these strengths are. So when we talk about Wi-Fi with the trademark of the 802.11 things that we see floating around, that's the use of radio waves to allow connectivity to the internet with a particular area. Wi-Fi's strength is data continuity, streaming, and computing. When we talk about distributed antenna systems, that's a distribution of a cellular signal inside of a building. Dash/in-building wireless, its strength is voice, taking the cellular signal that we all have outside and bringing it inside seamlessly into the building. Yes, there is voice over Wi-Fi. However, that is not Wi-Fi's strength. And yes, I can stream with cellular, but again, that's not its strength. These two complementary technologies create a seamless connectivity. And yes, they have overlap, which is great, but we need to also remember what they have as their strength. We want to make sure that we ensure mobility for both staff and equipment, improving our patient and guest experience, and reducing the risk and cost of overall equipment. As we have been discussing here, there is an abundance of wireless devices from wearable monitors to building system sensors, nurse call station, and the list goes on. Not to even mention the safety of patients, staff, and visitors both in the building and entering and leaving the facility. And that's why it's so important to not think of these as a versus, but think of these two systems as a complementary system.
So building off of that, Jill, can you tell us a little bit about what's going on in the Wi-Fi market as standards evolve?
Yeah, standards have been evolving pretty quickly here in the Wi-Fi space. And, one of the things that you'll kind of see here on this slide is that on the left-hand side, everybody's kind of been referring to these Wi-Fi networks with letters, which has gotten to be really, really confusing to know which one came first and which one came later. So they're now starting to flip that over into numbers, which makes it much easier to keep track of. So, for example, 802.11n is now being referred to as Wi-Fi 4. And the newer 802.11ax is now being referred to as Wi-Fi 6. And there's even this potential of the future of something called BE, which we're calling that might even be Wi-Fi 7 and have the capability to exceed 10 gigabits per second. And you can kind of see the way that on this chart here to show how quickly Wi-Fi 6 is expected to kind of take over the market just because of the change in its capabilities. And as we move on here into this next slide, you'll kind of see the differences as we look into between Wi-Fi 4 and Wi-Fi 7, the densities that are required and the types of cabling that is required as well. So if we were to talk about that here and think about the building that we have today, and maybe today in our building we have a Wi-Fi 5 point. And if we were to transition to Wi-Fi 6 today, then that would require us to add probably about twice as many wireless access points or WAPs that we have today. So again, I'm going to take one cabling connector of a Cat6a cable, and now I'm going to require two Cat6a cables because I have twice as many devices. And then the estimate is that as we move into Wi-Fi 7, this yet to be determined one, the amount of distribution of the WAPs will remain about the same as we had with Wi-Fi 6. But the challenge now is that each one of those wireless access points is now going to need two Category 6A cables. So the recommendation for anybody installing or modifying a building or doing a new construction is to make sure that we're allowing for these increased densities and that we're looking to potentially make sure that everybody has the capability to have, if they're on 5 now, a capability for 4 connection points as we move into the future. You don't necessarily have to run those cables in the ceiling, but certainly making sure that whether it's at a consolidation point somewhere or a zone box somewhere, that you have that capability in those open ports so that you don't have to run new cabling back to an overall TR room to be able to have that type of increased mobility in the future.
Technology evolves so fast. Power over Ethernet, or PoE, is a reality today. Just a few years ago, it was just an idea. How is PoE being used in healthcare environments?
Yeah, I think first let's talk maybe just a little bit about the number of PoE devices that have happened over in just this last year. It talks a little bit about how PoE devices, there were approximately 117 million PoE ports shipped in 2019, and the expectation is that PoE ports are going to continue to increase around 13% annually. And there's lots of applications for PoE, and all of these applications are part of the digital building, which certainly moves over into a healthcare space as well. From security cameras to badge readers to wireless access points to phones, all of those are PoE enabled. And then the other challenge to think about when we talk about PoE is to consider that when you're running power over an Ethernet cable, you're certainly going to have more heat. And when you disconnect something that's under power, there's always that potential to have a spark. And so when you're laying out those systems, you need to take that into consideration and choose equipment or products that enable PoE or are maximized with the PoE capabilities that take that into consideration. And now we'll walk through a little bit of an example with how PoE can be used inside of healthcare. This is just an example of PoE lighting. We mentioned it a little bit earlier, that there's all different kinds of lights. And so let's just walk through a pretty easy example for us all to follow from a lighting perspective. imagine you're teaching a class of kindergartners, and they've all come in the morning and they're all a little sleepy. And so in the morning, you need something that will energize them and keep them awake and keep them engaged with the teacher. Well, now they all come in from recess. They're pretty excited at this point. Well, now I might want some type of a light that's a little bit warmer that enables them to calm down a little bit before we re-engage them. That's the same type of a thing that is an advantage inside of a healthcare facility. There's all types of information. We all know that a more natural light makes us feel much better than a more hard light does. And so if I can create those types of scenarios inside of a healthcare facility and allow it to change throughout the day from when I have a lot of sunlight to when I don't have a lot of sunlight, that can actually enable a healthcare facility to increase their overall scores amongst the consumers. There's also other innovative ways that light can be used inside of a healthcare facility, from noise management. Certainly hospitals are typically quiet places. And let's just say that an area gets a little bit louder and that noise starts to travel out into the hallway. What if I had lights that could blink and let me know that I've maybe increased my noise? Or we had talked previously from an amber light perspective that at night, everything just kind of turns to an amber tone so that I can sleep and the people inside the healthcare facility can still work with people that they need to go in and check on. So PoE lighting is just one example of how PoE can be used inside of healthcare.
Jill, let's switch gears and talk about cloud computing for a bit. Organizations are beginning to realize that moving everything to the cloud just isn't realistic or beneficial for a variety of reasons. So how does the concept of edge computing play into that? And what are the implications for and benefits to healthcare providers?
So edge certainly starts with an overall hybrid IT approach. Organizations have been employing hybrid IT strategies after decades of just thinking about the old cloud-first approach. We now have enough real-world experience with the cloud to understand where it delivers on its promises and where it falls short. Organizations are selectively deploying applications across cloud, multi-tenant data centers, colo, and some on-prem edge environments based on data efficiencies and security. Data efficiencies include things like latency, sensitive applications, impacts to an application's performance, and optimized user experience. So as we kind of walk through this, you can't really go directly from just having one type of a data center or a place that you store and you work on your data to just jumping directly to edge. Edge is the process of moving the compute and store on a more simple network intelligence proximity to where the data is being generated. It can be analyzed and it can be used in that way. In this way, the edge is an evolution of the network architecture that complements the cloud by serving latency-sensitive applications, optimizing the overall network access and transparent resources, and delivering the data to users for a timely analysis that benefits not the normal transfers that you would see from the cloud. Now, I think one of the confusions that happens when we talk about edge is a lot of people confuse edge with a definition for the applications at the edge. Applications are wide and varied from, the autonomous car. That is an edge application that could potentially need an edge data center, but they are not the same type of terminology. So edge is not the opposite of cloud. It is a complement to the cloud. It enables data that needs to be acted upon right there on site in a low latency type of a way to make that data available to that person immediately. Whereas opposed if you send it to the cloud, it does all of that number crunching and then it sends it back down. You've lost some of that quickly timeliness. The other challenge is I think a lot of people have realized that if I send everything to the cloud, that's a lot of data and I'm paying for that data space. So if I can only send data to be stored, whether it's inside the cloud or inside of my own data center that actually needs to be saved, and I'm not just sending data there to just send data, and I'm acting on that data on site where I need to and then recording the data that needs, I can actually reduce the amount of storage space that I need in the future. So a really good example of how edge can be used inside of a healthcare facility is some of those things we've talked about over the past couple of slides here, is that if I'm in a remote location, I'm not at the hospital, and I'm recording data and something is happening in one room and somebody walks in, they have that data and that AI happening right there and then as they need it. And that data that is being stored is the data just on that patient after it's been acted upon. So that's kind of a way to think about edge and how it can be used inside of the healthcare space. And it's certainly an evolving item as well. And when we think about edge, it enables a healthcare provider with a couple of benefits. First, it can help them to lighten the workload of what they do on a day-to-day basis. It helps them to by removing less important tasks, such as collecting data and managing that patient data. So everybody likes to input data in a different way. And so if an edge application can take all of that data and formulate it into the same type of a format, that makes easier analysis and data storage in the future. The second is it can help to make healthcare more affordable and accessible, especially for remote areas where medical care falls behind. So imagine a truck outfitted with edge computing devices, for instance, in an isolated village, providing advanced healthcare by connecting residents to a telemedicine service. This is, distributed edge architecture, and it's less prone to a massive system-wide failure that a centrally controlled cloud computing system would have. The third benefit that we might see is it can help to stimulate medical technology advancement. As we all know, in the era of big data, more data equals more opportunity. Edge computing will make it easier to manage and label data in a uniform and efficient way, and will make it easier for colleagues to share data securely. Enabling technology development by allowing research to be able to mine the data that maybe was unavailable in the past or wasn't formatted in such a way that they even knew that they were looking at the same thing. So an example of this would be an intensive care unit sensors that require instantaneous analysis of data and execution of commands, such as a closed loop system that we might call it. A sensor becomes more sophisticated, and we'll see similar closed loop systems in the future for monitoring insulin levels, respiration, neurological activities, and cardiac systems in the future. All of this leads to many benefits for the facility as well as the consumer.
So, Jill, with all this great digital potential that we're talking about, it really does come down to infrastructure, doesn't it?
It really does. And I think one of the things that a lot of people forget about, and I always like to use the analogy of a road and a car. We all like to buy fancy cars, and we all like to have that experience. And I can buy the fanciest car, or let's just call it the fanciest active device, inside of a healthcare facility for whether it's my IT management or even a physical medical piece of equipment. But if the road that I'm putting it on is not robust, then I'm not going to get that experience out of that car or out of that device that I was expecting. And so that's why infrastructure is kind of like that silent road that we don't really think about a lot. And you can kind of look here from the data that it's about 5% of passive physical infrastructure typically represents less than 5% of the total CapEx. So we spend a lot of money on the active equipment. We forget a lot about the passive because it's not a high cost dollar. And so I think that's one of the things to keep in mind is that you can really future-proof yourself so that you're not having to replace the infrastructure as you move into the future. If you just spend a little bit more, when you think about the overall theme of what you're spending, it's really, again, pennies on the dollar. And when we look at healthcare facilities, something to keep in mind is that 60% of our hospitals have network cabling over 10 years old, and 42% of them have cabling over 15. So that's one of the things to keep in mind. We're probably not going to be building tons of new hospitals and healthcare facilities. A lot of it's going to be upgrading what we have and making sure that we're making the best use of it and understanding that it will certainly lead to benefits in the future.
Can you take a couple of minutes to touch on how Panduit enables and supports state-of-the-art healthcare facilities?
Yeah, I think one of the most unique things about Panduit and my time at Panduit is that most customers don't know everything that Panduit has the capability to be able to do. Whether it's on our electrical side with wire ties and terminals, on our data center side with cabinets and containment, on our enterprise side with copper cabling and connectivity, there's not a customer that comes into what we call our experience center and doesn't leave without saying, I didn't know you did that. So I think that is the biggest challenge that Panduit has, is that we work with all different types of customers Through our distribution channel and through our contractors and system integrators and consultants that we have partnerships today, and helping them to realize that Panduit has a lot to offer, much more than just the best enterprise infrastructure system that you can have, or the best data center infrastructure that you can have, and the best electrical infrastructure that you can have. Panduit can tie an overall solution together, bridging across all of those entities to make sure that our partners and end users have the best solutions for their customers and for the future. So I think that is the thing that I want to challenge everybody with, is that Panduit's probably different than who you think we are. We're probably a little bit bigger than that.
Wonderful wrap up, Jill. Thank you. But unfortunately, that's about all the time we have for our webcast today. I'd like to thank our guest, Jill Shea with Panduit, for providing her expertise and insights on the benefits of digitally connected healthcare. And thanks to you, our audience, for joining us. For additional information on this topic, please click on the resources section on your screen. For Panduit and IDG, I'm Ed Murray.